Hello students, welcome to this session. In this session, I am going to discuss about Thevenin's theorem, which is the one of the most important theorem for your basic electrical engineering subject. Okay, in this theorem, there will be lots of questions asked, so kindly listen to the video carefully. So let us start with the statement of the theorem. The Thevenin's theorem states that any linear circuit containing several voltages and resistance can be replaced by just one single voltage in series with a single resistance connected across the load. So, the whole circuit of any network can be replaced by a single voltage source, which is Thevenin's, and single resistor, which is R Thevenin. So single voltage, so how many voltages or current sources are there? They can be replaced by a single voltage source V Thevenin and the resistance with the R Thevenin. So which is connected across to the load. So you can see here that it is Thevenin's equivalent is nothing but a voltage source in series with the resistor which is connected to the load. So let us move on to the problem. So using Thevenin's theorem, find current passing through R5 resistor for the circuit shown in figure. So this is the question asked in 2020 BEE. So here they are being asked us to find the current flowing through R5 resistor, that is nothing but this 30 ohms. Okay, so here we need to find out the current. So how to solve this network? So first we have to find the R Thevenins, as we have to find two terms here. One is V Thevenins and another one is R Thevenins. So let me start with finding the R Thevenins. So first step is to find R Thevenins. So how to find R Thevenins? So for the given circuit, you need to remove the resistor where it is been asked for voltage or current. So this resistor is known as now load resistor, because that is the point where they are asking us to find the current. So remove the load resistor and replace all the sources by its internal resistance. That is, for voltage source we know internal resistance is 0 ohm, so it is replaced by a short circuit. And for current source, the internal resistance is infinity ohm, so it is replaced by an open circuit. So here you can see that we have a voltage source, so we need to replace this by a short circuit by opening the terminals and finding the resistor equivalent, that is R Thevenins, which is the equivalent resistance between these terminals through the load. So first let me redraw this circuit so that you can understand what I am telling. So you can see here, I am just removing the load resistor and drawing the circuit. Okay, so this is the voltage source which is now replaced by a short circuit, and this is your R1, this is your R2, this is your R3, and this is your R4. And let me write it as A and terminal B, so that we can know we have to find R Thevenins across resistor, across the terminals A and B. Okay, so if you observe here, if I take this terminal outside, the circuit is nothing but series combination of two parallel resistors. Series combination of two parallel resistors. So this is nothing but your A and this is nothing but your B. You need to have your imagination to work here. So if I take this terminal out, and you can see that R3 and R1 are in parallel, and there is a short which is applied across between this R1 and R3, and on the other side R2 and R4 are in parallel. So this is how I am going to draw it. So R1 is 10 ohms and R3 is 20 ohm. Similarly, R4 is 50 ohm and R2 is 20 ohm. So you can see here 10 and 20 are in parallel, 50 and 30 are in parallel. That combination is in series. That combination is in series. 50 and 20, 10 and 20. That combination is in series. So first I'll write the equivalent value of resistance so that we can know what we are finding. Okay, this is nothing but your R Thevenins, what we are finding. So R Thevenins is nothing but 10 in parallel with 20. This is in series with 50 in parallel with 20. Okay, so 10 in parallel with 20 and 50 in parallel with 20. So the value of this 10 in parallel with 20 is 6.66, and that of 50 in parallel with 20 is 14.28. So the total R Thevenins is nothing but 20.94 ohms. So this is your R Thevenins value. So I am repeating it again, how to find the R Thevenins. So to find the R Thevenins, we need to remove the load resistor where they are asked to find out the current. So I am removing this load resistor R5 and replacing the sources with its internal resistance. So as there is a voltage source for this circuit, I am replacing it with a short circuit. If there is a current source, then we need to replace it with a open circuit, and then across the terminals we are going to find the resistance. So depending on the circuit, the value of R Thevenins can be found out. Okay, the value of R Thevenins can be found out. So this is the first part, that is R Thevenins we have found out. Next we have to find out V Thevenins. Now for finding V Thevenins, this is my second part. So to find V Thevenins, what I have to do is, I have to now for the same circuit, we have to remove the load resistor, remove the load resistor, and place the voltage source at the position which is in original circuit, given in original circuit. That means I am just now replacing the I am just placing the voltage source as it is, and I am removing the load resistor. For the previous circuit, instead of placing it as short circuit, now a voltage source is applied. Now a voltage source is applied. Okay, so what is the value of voltage source given? It is 10 volts. This was 10 ohm. This was 20 ohm. This was 50 ohm, and this was 20 ohm. So we have to find the voltage across this load terminals, voltage across this load terminals. So this is A and B. Okay, this is the A and B where we have to find the voltage across the load terminals, right? So as usual, we need to find the voltages. So to find this voltage, here you can observe that this voltage V Thevenins is nothing but the voltage across this 10 ohm resistor, and the difference between the voltage across this 10 ohm resistor and 20 ohm resistor. That means it is acting as a loop, and we can write the loop equation. Okay, and we can write the loop equation for this circuit. So that is nothing but V 10 ohm, let this be plus minus, because the current is flowing from the source like this. This is my total current. This is the current path which is flowing, and this is also the current path which is flowing. So plus minus, so plus V10 plus V Thevenins minus V20 is equals to 0. Minus V20 is equals to 0. Okay, so this is what we need to find out. From this we can find out the V Thevenin's value. That means we need to find out V10 ohm and V20 ohm. Okay, so let us find V10 ohm and V20. So how to find V10 ohm and V20? V10 ohm is nothing but the current flowing through the 10 ohm into the value of the resistor. So what is the current flowing through the 10 ohm? You can observe here the circuit is nothing but a parallel combination of series. So first we need to solve it and find out the currents I1 and I2, that is I10 ohm and I20 ohm, and then we can find the voltages. So V10 ohm is this one and V20 ohm is I20, the current flowing through the 20 ohm into the value of the resistor. So as this circuit is a parallel combination, let us find out total current IT, that is nothing but V divided by R equivalent. Now what is R equivalent? R equivalent is 10 plus 20 because they are in series in parallel with 20 plus 50. Yes, so 10 plus 20, these two are in series, and 20 plus 50, these two are in series, and that combination is in parallel. So it is 30 in parallel with 70, and this value is nothing but your 21 ohm. So R equivalent is 21 ohm. Now what is I total? I total is equals to 10 divided by 21. So its value is 0.476 amperes. 0.476 amperes. So this is the current which I have found as 0.476 amperes. Now I need to find out the current flowing through 10 ohm and the current flowing through this 20 ohm. So we can apply here current divider rule. By applying current divider rule, I am finding the current in 10 ohm and 20 ohm. So I 10 ohm, that is the current flowing through the 10 ohm resistor, equal to total current into opposite branch resistance. What is the opposite branch resistance? It is 20 plus 50 divided by total resistance. Total resistance is 10 plus 20 plus 20 plus 50. Okay, plus 20 plus 50. So what is the value? Its value is 0.476 into 70 divided by 100. So this value is 0.334 amperes. Similarly, I20 ohm. I20 ohm is equals to I total into opposite branch resistance. What is opposite? 10 plus 20 divided by 100, that is 10 plus 20 plus 20 plus 50. So its value is 0.476 into 30 divided by 100. So its value is 0.142 amperes. 0.142 amperes. Now if you want to check, you can check whether the total current is same or not. So what is the value of total current we have obtained? It is 0.476. Now what is the value of current in 10 ohm? It is 0.334. Similarly, what is the value of current in 20 ohm? It is 0.142. So you can check it here, 674. So 0.476. So it is same current what we have obtained. Now find out the V10 ohm, because I am saying, it is a loop. So if you consider it as a loop, then we can find out the voltage. So V10 ohm, what is V10 ohm? V10 ohm equal to current flowing through 10 ohm resistor into value of resistor, that is 10. So current flowing through 10 ohm resistor is 0.334 into 10. So its value is equals to 3.34 volts. Okay. Similarly, V20 ohm is equals to the current flowing through 20 ohm resistor into value of resistor. So it is 0.142 into 20, which is equals to 2.84 volts. Okay. Now apply to the equation. Now apply to the equation. So V10 ohm plus V Thevenins minus V20 ohm is equals to 0 because it is according to KVL equation. So V10 is 3.34 plus V Thevenins minus 2.84 is equals to 0. Therefore, V Thevenins is equals to minus 0.5 volts. Minus 0.5 volts. So now we need to find out the current flowing through the R5 resistor, which is the thing we asked in the question. So first we have to draw the circuit. We have to draw the circuit. So what is that? This is your V Thevenins, this is your R Thevenins, and this is the load across which you have to find the current. So R5, this is 30 ohms. This is what it is being asked us to find. This is your R Thevenins, whose value is 20.94 ohms. And this is your V Thevenins, whose value is minus 0.5 volts. Minus 0.5 volts. So I5 is nothing but V divided by R equivalent. Now V is minus 0.5 and R equivalent is R Thevenins plus R5. So I5 is equals to minus 0.5 divided by 20.94 plus 30. So the value of the current which is flowing here is minus 0.098 amperes. And as it is minus, here we can see that, instead of it is flowing from point A to B, it is flowing from B to A. It is flowing from B to A. Or you can see here the symbol of the voltage is at minus, right? So I am redrawing this circuit, according to polarity, of voltage. So what is that? It is, the top portion is the negative plate and the bottom portion is the positive plate. So this is V Thevenins is equals to 0.5 volts R Thevenins, and this is your R5, and this is how now the current is flowing from B to, okay. So this is how you are going to find the value of the current or voltage which is asked in the question. So in this session I am going to discuss about Norton theorem, okay, which is the exact converse of Thevenin's theorem. That means in Thevenin's theorem we have found out the equivalent circuit as a voltage source in series with a resistor, and that is connected to the load, whereas here we are going to find the exact opposite to it. So let us start with the statement. So Norton's theorem states that it is possible to simplify any linear circuit, no matter how complex it is, to an equivalent circuit with just a single current source and parallel resistance connected to the load. So if you observe the figure here, in Thevenin's theorem we have checked it as voltage source in series with a Thevenin's resistance, which is connected to the load. So this is your V Thevenins, this is your R Thevenins, and this was your load. So now here you can see that it is the counterpart of this circuit, that is a current source instead of a voltage source, and the parallel resistance instead of a series resistance, which is connected to a RL, that is load resistor. Okay, so whatever the circuit is, like it has any number of current source or voltage source, can be now replaced by a single current source, which is represented as I suffix n, that is Norton current, in parallel with the resistor R suffix n, that is Norton resistance, which is connected in parallel to the load circuit. Okay, so let us see examples. So this is the question in 2020 BW exam for 9 marks. So using Norton's theorem, find the current in 6 ohm resistor. So where is the 6 ohm resistor? It is across the terminals A and B. Okay, so even though they give the terminals A and B or not, when you are asked to find the current in any resistor, you need to just replace that with the terminals A and B. Now, first step in Norton resistance, Norton circuit is same as that of Thevenins. That is, here we are going to find out Norton resistance, which is similar to Thevenin's resistance, which is nothing but the Thevenin's resistance. So, what we have done in Thevenin's resistance, we have removed the load resistor, and replace all the sources with their internal resistance. Replace the source with its internal resistance. Okay, so as here it is a voltage source, we are going to replace this with a short circuit, because we know that the internal resistance of an voltage source is 0 ohms. So it is a short circuit. So now the circuit is a short circuit and it is connected to 3 ohm. Here it is 5 ohm, and that is connected to 4 ohm, and this is terminals A and B. A, B, this is where we are finding the Norton resistance. So it is 4 ohm, 5 ohm and 3 ohm. This is the voltage source which is replaced by a short circuit. Okay, so what is the value of Rn? Rn is nothing but 3 in parallel with 5, and that is in series with 4. So the value of this Norton resistance is 5.875 ohms. 5.875 ohms. Now we are going to find out our second step. There we have found out V Thevenin. Now here we are going to find out I Norton current. So for this, what you have to do is, instead of removing the load resistor, we are going to short circuit the load terminal. That is, short circuit the load terminal and find the current across it, and find the current across the short circuit. Okay, so then a circuit will now become as a voltage source 5 volts is in series with 3 ohm resistor, and that is connected to like this. This was the terminal A and B of 6 ohm resistor, where we are going to find Norton current. Okay, so this is 4 ohm and this is 5 ohm. So in Thevenin's theorem, we have found out V Thevenin across the load terminals. Now we are going to find the I Norton, that is current across the Norton circuit. So here if you observe, what is IN? IN is nothing but the current flowing through 4 ohm resistor. So to know the current flowing through 4 ohm resistor, we need to first find out the total current. So how to find out total current? Total current is nothing but voltage divided by R equivalent. Now what is R equivalent for this circuit? You can see here, as 4 and 5 are connected between common terminals, they are in parallel, and that is in series with 3 ohm. So the value of equivalent resistance is 5.22 ohm. Okay, this is 5.22 ohm. So total current is nothing but I total is equals to 5 divided by 5.22, which is nothing but 0.95 amperes. Okay, 0.95 amperes. So here I have got 0.95 amperes. Now I need to find out the current flowing through 4 ohm, that is my Norton current. So current flowing through 4 ohm is nothing but my Norton current. So it is obtained by using current divider rule. Total current into opposite branch resistance divided by total resistance. What is the total current? 0.95 into 5 divided by 9. So the value of this is 0.528 amperes. Okay, so value of my Norton current is 0.528 amperes. Okay, so how we have done it? We have just replaced the load terminals with short circuit and found the current flowing through that short circuit element. Now the total circuit is being replaced as Norton current, a current source in parallel with a resistor. Current source in parallel with a resistor which is connected across the load terminals. So this was 6 ohms. This is Rn. What is my Rn? Rn is 5.875 ohms and my Norton current In is equals to In is equals to 0.528 amperes. 0.528 amperes. So to find this I6 ohm, we know that we can use the current divider rule. So by using current divider rule, what is that current divider rule? So I6 ohm equal to total current, that is nothing but my Norton current which is flowing till here, and again it is being divided. This is for Rn and that is for 6 ohm. So here what can I say? Norton current into opposite branch resistor is Rn divided by Rn plus 6. So it is 0.528 into, what is my Rn? Rn is 5.875 divided by 5.875 plus 6. Okay, so my 6 ohms current is nothing but my load current, which is equal to 0.26 amperes. 0.26 amperes. So what we have done? We have, for any circuit, to find out the Norton equivalent, we have to first find out the Norton resistance, which is similar to the Thevenin's resistance. That is, we have to remove the load resistor and replace all the sources by its internal impedance or internal resistance, and we are going to find out the value of the Norton resistance across the terminals AB. Then to find out Norton's current, we have to short circuit the load terminals and we are going to find the current flowing through that load terminals. So that current is nothing but my Norton current. And again, to find the load current, we have to have a parallel combination of Norton current and Norton resistance which is connected across the load, and this is how we are going to find out the Norton's circuit for any given circuit. Okay, and this is also equals to Thevenin's circuit also. That means here you can also solve this with the equivalence of Thevenin's circuit. So let me do that. So Thevenin's voltage V Thevenin's is nothing but I Norton's into R Norton's. It is according to source transformation. It is according to source transformation. We know that Voltage is equals to current into resistance. This is what we are getting. So 0.528 into 5.875. So we can use this Thevenin's theorem also to find out the equivalent value of the current flowing through the load circuit. So which is equal to the value of voltage is nothing but IN into RN, that is Norton current into Norton resistance, which is according to source transformation. So its value is 3.102 and this value is, so let me check whether it will give us to same value of the current flowing in 6 ohms or not. Okay, so I'm just drawing it. This is your R Thevenins, this is your V Thevenins, this is your load resistor. So the current flowing through the load IL is equals to V Thevenins divided by R Thevenins plus RL. So V Thevenins is 3.102 divided by R Thevenins is 5.875 plus 6. So its value is equals to 0.26 amperes. Okay, so either you can do in Norton's theorem or you can do in Thevenin's theorem. And if you have a Thevenin's circuit and you want the Norton circuit, then it will be V Thevenins by R Thevenins is equals to IN, and RN is nothing but the R Thevenins. Similarly, the counterpart for the Nortons to Thevenin. So this is according to source transformation. This is very important for your objective bits.